Find the derivative of y equals 2x cubed minus 4x squared plus 5x minus 3 all over x squared plus 4. Then evaluate y prime of 2. Y here is the quotient of two separate expressions, 2x cubed minus 4x squared plus 5x minus 3 divided by or over x squared plus 4. We're therefore going to use the quotient rule for the derivative. Y prime, or dy dx, will be, using the quotient rule, derivative of the numerator. First term, bring down the 3, 6x to the 2. Negative 4 times 2 will be negative 8, x to the first. Plus 5 times x will just become a plus 5, and then the negative 3 will be a 0. Derivative of the numerator times the denominator left alone minus the numerator left alone, 2x cubed minus 4x squared plus 5x minus 3 times the derivative of the denominator. Power rule. Bring down the 2, subtract 1 from it. 2x, derivative of 4 will be a 0. All of this over the denominator squared. X squared plus 4 squared. The numerator can be simplified. Y prime, or dy dx, will equal, and it will be simplified by expanding. The first thing we're going to do is the FOIL of these three terms with these two terms. 3 terms times 2 terms will give us 6 terms total. We're going to take the 6x squared, multiply it times the x squared and the plus 4, and then the negative 8x times each, and then the plus 5 times each, in that order. 6x squared times each of those will give us 6x to the 4th plus 24x squared. Now the negative 8x times each of those will give us a negative 8x cubed and a minus 32x. And now the plus 5 times each of those will give us a plus 5x squared and a plus 20. This other expression, we have a 2x and a negative that needs to distribute into each of those terms. So we're going to multiply by a negative 2x. Negative 2x times a 2x cubed will be a negative 4, and then x to the 4th. A negative 2x times a negative 4x squared will be a positive 8, and then x to the 3. A negative 2x times a positive 5x will be a negative 10 x squared, and a negative 2x times a negative 3 will be a positive 6x. All of this over that same denominator, x squared plus 4 quantity squared. We can now combine like terms together, and y prime, or dy dx, will be, we have a 6x to the 4th, and we have a negative 4x to the 4th. 6 minus 4 is a 2x to the 4th. We have a negative 8x cubed, and we have a positive 8x cubed. Those will cancel. So let's just cancel those terms out. That'll make our expression a little easier to deal with. We have a 24x squared, a plus 5x squared, and a negative 10x squared. 24 plus 5, that's 29, and then minus 10, which will be a 19x squared. We have a negative 32x and a positive 6x. Negative 32 plus 6 is negative 26x. And then we have only one constant, a plus 20. all this over x squared plus 4 quantity squared. So there's our derivative y prime, or dy dx. The next thing to do is evaluate y prime of 2, which means to plug a 2 in for each of the x's. Y prime of 2 will be 2 times 2 to the 4th plus 19 times 2 squared minus 26 times 2 plus 20. All of this divided by 2 squared plus 4 and then quantity squared. In the numerator, 2 to the 4th, 2 times 2, 4, times another 2, 8, times 1 more 2, 16, plus 19 times 2 squared, which is a 4, minus 26 times a 2 will be a negative 52, and then plus 20. 2 squared is 4, so we have 4 plus 4 quantity squared in the denominator. 2 times 16 is 32. 19 times 4 is 76. Negative 52 plus 20, that'll be a negative 32. All divided by 4 plus 4, which is 8 squared. Now nicely, there's a positive 32 and a negative 32 in the numerator. We can cancel those out. And I'm ending up now with a 76 over 8 squared, which is a 64. Each of these are divisible by at least a 2. Let's divide a 2 into each of them. 76 divided by 2 will be a 38. 64 divided by a 2 will be a 32. Well, it turns out that they're again divisible by 2, so they must have been divisible by 4 to begin with. But we'll just take it in steps, a 2 and then another 2. Divide each of these by 2. 38 divided by 2 is 19. 32 divided by 2 is 16. And we're ending up with 19 over 16 for y prime of 2.